Welcome everyone and thanks for joining us today. My name is Jocelyn and I'm the marketing coordinator here at Double Radius. As always, our goal for today is to share knowledge to help you build better networks. We have a great webinar for you today as we host Cambium Networks to talk about unleashing the power of cnWave 60 GHz. Making the presentation today is Bruce Collins. As Senior Director of Product Management at Cambium Networks, Bruce manages a portfolio of wireless broadband networking solutions, including 60 GHz millimeter wave, sub-6 GHz, and licensed microwave technologies. Before we jump into the presentation, a couple of important things to mention. First, we love questions, so please make sure to use the question box often. Go ahead and type in any questions as you have them throughout the presentation. In fact, just to make things more interesting, we'll be picking one lucky winner today from those who enter a question before the question and answer session starts. That person will win a Double Radius swag pack that includes a t-shirt and some other cool items. Second, after the webinar, a survey will pop up on your screen. Please take a minute for that as we'd really appreciate your feedback. And with that, let's get started. I'll hand it over now to Bruce to get us started.
All right, thanks Jocelyn, and thanks to the Double Radius team for putting this together. I have a pretty excited to talk about the cnWave 60 GHz product today. It's a brand new product from Cambium. We've been shipping it since about December, and it's arriving with Double Radius here as we get into the spring. So as Jocelyn mentioned, there'll be plenty of time at the end for questions, so please think about those questions and put them in the chat window for now. And then we'll have plenty of time to answer those as we go through the rest of the session. Today I'm going to cover not only a little bit about the technology of the product and the product itself, but I'm going to kind of go heavy on the actual applications and use cases, or how we see people using cnWave. So we'll be a little bit heavy today on applications and use cases, but hopefully that gives you an idea of what 60 GHz is being used for and how you might be able to use it within your operations. So let's go ahead and get started. The background on 60 GHz cnWave is it is a solution that Cambium has released, as I mentioned, back at the end of last year. Is just now starting to move into wider deployment, wider availability. It is based on the 802.11ay standard. So this is a standards-based product that's been championed by with a layer of technology on top of it called Terragraph, that's been championed by the Facebook connectivity team. And so this is a Terragraph certified solution, and we'll get into a lot more detail about what that means as we go through the session. But suffice it to say, it is a technology that is designed to scale up large deployments of 60 GHz solutions in a variety of topologies. Most uniquely is the mesh capability in the product associated with Terragraph. It delivers lots of capacity. So you're talking about gigabits per second to end users and multi-gigabits per second on backbones through the mesh to deliver lots of capacity to end users or businesses. Leverages beamforming for ease of installation. We'll get into what that means. And then the way the mesh works together with the beamforming and the management system to make the system easy to expand and auto heal with that multi-paths to each distribution node. We'll talk about different topologies and how people are using them, and then of course management. So a lot to cover, but before we get into that, I'm going to hand it back to Jocelyn to pop up the first poll question. We just kind of want to get a sense of who's on the call today. So go ahead, Jocelyn.
All right. What best describes your interest in 60 GHz? And we're going to give everybody about 30 seconds here to answer. And we'll give it about 10 more seconds. So 17% said already deployed, 39% said plan to deploy in the near future, 22% said considering deployment, and another 22% said today is my first time looking into it.
All right, great. So that helps, gives a sense of what people's different experience is with the product. I think it's interesting, and we'll get right into this topic of if you maybe have already deployed 60 gigahertz, we'll talk about what's new and available in the latest standard, and with especially with the Terragraph certified capabilities. And then for those of you that are just kicking the tires or just getting involved or interested in it, hopefully this will give you a good overview, and you can go find more information on our website and other sources online. One of the things that's evolved recently is this 802.11ay standard. So while 60 gigahertz solutions have been deployed, probably going all the way back to like 2010, I think, in 2012, in that ballpark, uh, most of those are deployed on what's called an 802.11ad standard. And what's emerged recently is the AY standard. And highlight here a couple of the key differences. One is the capacity and throughput has doubled with AY standard. This is largely through the ability to bond multiple channels together. So the channel allocations are the same, or the channel planning is the same. It's a 2.16 gigahertz wide channel, 2160 megahertz, as you can see there. And then with the AY standard, you can bond two of those channels together and double the capacity in most cases. The way that the older standard AD standard worked was using what's also kind of the Wi-Fi approach, which is that CSMA, carrier sense multiple access, where each device kind of wakes up and says, here I am, I'm ready for some data, versus a TDMA TDD approach, which is a scheduled air interface where time is allocated by in this case, the distribution node, or the access point, configures and controls that air interface so that each device has a known time when it can speak and when it should listen, and which allows you to significantly scale up these networks. Aligned with that or associated with that is the ability is network synchronization. So all of that timing and that air interface is all timed together using a GPS signal. So you have this precise timing of when each device is talking and when is it listening. Of course, AY adds the mesh support. So that's the ability to really, and you'll see this in the different topologies and how that's leveraged, but it allows you to have multiple paths and multiple ways to get back to the fiber nodes or the POPs, and you can have multiple POPs in the network. So you can really start to distribute that capacity throughout the area that you're providing coverage. And the number of CPUs has effectively or almost doubled. So you have 15 CPEs per sector versus the 8 in the AY. So it really is just a significant evolution in the capabilities of using 60 gigahertz spectrum, which is quite a valuable spectrum because it does give us so much bandwidth and capacity. So some of those benefits, I kind of hit them on the previous slide, but TDMA, TDD really is all about scaling up and putting lots of nodes in a given geographic area. And you can also get reuse of a single channel. So most of the designs and most of the deployments that you see here today will be based on a single channel design. So you can reuse that single channel multiple times over and over again by leveraging the TDMA, TDD, and the network synchronization capability. So it really minimizes the self-interference. Channel bonding we talked about, of course, that's just effectively doubling your capacity. In almost all modulation levels, you'll see a doubling in capacity. And the mesh routing, which is really, along with the high capacity and multiple gigabits per second of throughput, this standard and the cnWave product in particular allows you to serve that with very low latency. So we're talking sub 1 millisecond latency in most cases. So really high performing network with auto healing and expansion. So you can really start to add nodes, and if a node was to go out of service, the network can self-recover or self-heal. So lots of really nice technical features, but I want to really spend more of the time today on how these are used, and then we'll talk about the products as well. So let's talk about the architectures. I know many of you may be coming from, especially from the poll, many of you may be just learning about 60 gigahertz, or just maybe you're coming from a 5 gigahertz wireless ISP background, or a outdoor Wi-Fi access point background. So there's a few differences in how 60 gigahertz is deployed, and I want to kind of start there. You'll see a kind of a reference diagram here on the left, and some of the different topologies that we talk about in 60 gig is wireless to the home. So this is one that you would be familiar with. This is where I have a distribution node or distribution layer, and then sort of that last hop over to an individual residence's home. So I can put one of these cnWave devices on residence's home and offer hundreds of megabits per second and even gigabit per second service to that residence. We also offer wireless to the building. So that can be that same multi-gigabit per second connection using our high-speed backhaul or as a distribution node to a client node at a business, and then break that down into individual sub units or multi-dwelling units and offer that service through either Wi-Fi or the wired connections within the building. Rooftop to rooftop, this is an application that in most cases lends itself to think of an enterprise or a campus where you're trying to deliver high capacity from building to building without having to trench cables into the ground or run fiber through the air. So you really have that opportunity to expand capacity throughout an environment or an enterprise environment. And you'll see in many of these cases, 60 gigahertz can complement fiber. So while certainly you can deploy wireless more quickly than fiber in most cases, and you can put the wireless connection where you need it because you're not tied to where the fiber is lying in the ground. It is complementary to fiber. So if you're deploying fiber today, one use case is to extend that fiber either maybe it goes across a right-of-way access area that you can't get the fiber across, like a highway or a river, but you can extend this with a high-capacity point-to-point link or a high-capacity multi-point link, or extend the mesh across that void. So it really can operate in cooperation or complement that fiber deployments that you're doing. And then the last type of key topology or deployment architecture is just as a pure backhaul. And this is really, think of this as a distributed backhaul. So it can be done as a point-to-point link, but it can also be done as a distributed backhaul where you string, and I have some examples I'll show you, where you can string what we call distribution nodes along a path and then have branches off of that backhaul serving. And now I have a gigabit per second backhaul, multiple gigabit per second backhaul, and I can feed either 5G small cells, outdoor Wi-Fi access points, micro pops for fixed wireless broadband using some of our other some of the Cambium's other products, as well as there's a pretty significant use case of 60 gig in CCTV and video surveillance applications, because again, it gives you all of that capacity that you can feed lots of video. So this kind of still a little bit more of a theoretical slide, but it shows you kind of the different architectures and topologies on how the system goes together. I mentioned it fits in nicely with Cambium's overall wireless fabric. This is what we talk about when we say we can deliver wireless to different speeds and locations, and all of it being done through a single pane of glass management using our cnMaestro solution. So again, the cnWave really complements what we are able to do with things like our CBRS solution at 3 gigahertz, our PMP450 or ePMP platforms at 5 gigahertz, and as well as complementing with our licensed microwave and outdoor and indoor Wi-Fi access point solutions. So really, from Cambium, you can get all of these different pieces, and they all fit together within that overall cloud management architecture. So let's get into some specific examples. And I'm going to start kind of in the middle, urban dense areas, and then we'll move out and show you some examples and how you can also leverage 60 gig in the rural areas. So start with city center. This is really high density areas, might be areas where there's a lot of fiber, but maybe it's hard to get fiber into some historic areas, or you don't have, in some cases, it may be very difficult to trench fiber or new fiber in places where you don't have it. So again, the topologies or architectures here are rooftop to rooftop typically, and it can be leveraged with the mesh capability. So here's a very specific example. This is YTL operator in Malaysia, and this is a good sized network, and it shows you in the dark red, you'll see the distribution nodes, and in the light blue, you'll see client nodes. And then the real dark blue is where they have are feeding this mesh with the fiber connection. So you're feeding fiber into this, and then using the mesh to distribute lots of capacity throughout this area where it was difficult to bring either copper or fiber to a lot of these residences and homes, or residences and enterprise customers. It's also being used to feed Wi-Fi coverage throughout this area, so that as a public Wi-Fi access, this becomes another service that it's offered by YTL across this urban area. So again, this is sort of the classic 60 gigahertz mesh architecture with lots of capacity and lots of density, and uses all of the products that we'll talk about here in a bit. Here's another example. This is showing not quite the city center, but maybe a little more of but still an urban environment. This is residential access, and it's also using the meshing capability to connect outdoor Wi-Fi across this whole area, so that you can have both public Wi-Fi access, but also Wi-Fi for some of the smart city applications, whether it's garbage collection or city services that are going to leverage this Wi-Fi access. 60 gigahertz becomes a nice backhaul solution to feed that capacity across this large area. So if we start to move a little bit further out from the cities into a suburban deployment area, you'll see that there's still a lot of applications for 60 gigahertz. In this case, you're seeing the distribution nodes serving client nodes at each home. And you'll see as I've got some slides later on that show you the range. You're typically talking about a couple hundred meters from distribution node to distribution node, and then maybe 100 meters to as much as a kilometer for point-to-point or longer distance links, but still relatively short links, close areas, and leveraging that distribution or distributed capacity type of architecture. And if you look at even a more rural area, so if some of you are on the call today are working with or as a wireless ISP in a more rural community, this is still an application for 60 gigahertz. And this is showing a small town in Texas that is using 60 gigahertz to serve the community. And if you think about even a rural community, there are still congregations of homes in small areas, and you can feed that with a mesh as they're showing here, and then extend out from there into the farming community or the surrounding areas with the more traditional 5 gigahertz or longer range links. But within that, within the sort of the village limits or city limits, you can use the 60 gigahertz to offer capacity that really competes well with a fiber operator or with a cable TV operator as a strong alternative with wireless. This customer is offering 100 megabits per second services, and then the aspiration is to move up to gigabit per second services as well, to all the way to an end user's home. So the business case and ROI and total cost of ownership really plays well with offering those gigabit per second services to enterprise customers. And as we talk about enterprise, here's an example of a industrial area with connectivity across multiple buildings. In this case, you've got multi-point going rooftop to rooftop, and then Wi-Fi within the buildings. And another example here is a more of an office environment, campus connectivity, where they've built a ring of distribution nodes around the core of their campus. You can see those different tripods, DNs 1 through 6, and then the fiber node, which is that POP DN1 up at the top. And then you also see the various spokes off of the interior ring going out to areas that they couldn't reach. You can see that one going extending across the highway, and then just off campus with those other spokes off of the key or the core ring. So again, another nice application, and this can be used as either a complement to existing fiber that's in the ground, so it could be a backup network, or it could be an extension where you really do just want to offer gigabits per second to multiple areas within the campus. And this is, I think, one of the last examples here, but this is a industrial area. It's actually a chemical processing facility where they wanted to put a lot of capacity on a grid fashion. And so the way the network design worked out is a nice, elegant grid there. And what they're putting in each of these cross sections is lots of video capacity or video surveillance for the capacity, but also the automation and monitoring of different services throughout this production facility. But the primary application has been extending high def video across this entire operating plant. And then here's a rail yard application, and this is again a video surveillance application, but also Wi-Fi for the technicians and automation within this train yard. And you can see that interesting architecture here is that they've put distribution nodes down both sides of the rail yard, and then you'll see some cross points in there. The green lines that cross over the tracks are really where you develop that mesh and resiliency in the design. So you've got lots of capacity going down the length of the yard, and then some mesh capability as you cross over the yard and coming back to the main injection point here with the POP node. So another clever application, but you can kind of see through all these applications, really the sky's the limit with this product as far as how you can deploy it and how you can build out high capacity networks. One last topic is 5G small cell backhaul. That is another key topology, if you recall from that sort of reference diagram. And what I'll show you here is a case study or an example of an operator who is deploying a 5G cellular backhaul. And there, you can kind of see from point A to point C there, there's a little bit of a curve in the street, and it's also an area where it would be difficult to run new fiber. But what they were able to do here is put a radio at point A, put a distribution node, relay node at point B, and then serve that customer at point C. So one of the key attributes of 60 gigahertz is that it must be line of sight. And this application leverages the relay capability and the meshing capability to deliver capacity down the length of this street as through a relay node. And you can see it's not a very, it's only looks like it's only about 75 or 100 meters down this street, but it would have been very costly and time consuming to deliver that kind of fiber connection in this industrial area. So another application. And that small cell, you could replace small cell with Wi-Fi access point. You could replace it with video cameras. You have a lot of different options in what you do as you string these along different street and cityscapes. So that brings us to poll number 2. Jocelyn, you want to pop that one up?
All right, which application would you most likely use cnWave 60 gigahertz for? And we're going to do another 30 seconds.
If there's applications you're thinking of that aren't on that list, we'd be interested to hear about those as well. So put them in the chat window. We can always talk about them later at the end of the session.
All right, 50% said residential access, 35% said enterprise, 0 said surveillance, 15% said public and private Wi-Fi, 0% said 5G small cell backhaul.
Okay. All right, well, that's interesting. So, residential and enterprise access kind of wins the day with this group. So, kind of makes sense. You might want to think about video surveillance as an application for this. We see that in other audiences when we talk to different people, but very um, very typically. A very typical application, of course, is residential and enterprise access. So we'll get into that here as we go through the rest of the presentation. So thanks for answering that. And let's start moving on and talk about more about the product itself. As I mentioned, the product has been released since late last year. We're starting to see more and more networks go on the air. We've done about 50 different proof of concept trials through the testing of this that started back in the middle of last year. So this product has been tested around the world in all different types of applications and use cases as we went through, and we continue to see that that number grow and increase rapidly. So very exciting time to have a look at this new technology. And let's talk about some of the numbers, and then I'll get into the products themselves. So this is a very typical set of numbers for a application that is using our V5000, which is our distribution node, out to a client node, which is a V3000 or V1000. So from a distribution node to our V3000 client, you'll see right around that 1.8 gigabits per second uplink and 1.8 gigabits per second downlink, whether it's TCP or UDP traffic. And these are the numbers that we talk about with cnWave are really uplink plus downlink. So you're able to do, you see even simultaneously there 1.76 and 1.74 uplink and downlink. So it's closer to an FDD type capability when you think about how much traffic you're delivering, though it is a 50-50 TDD interface. But when we talk about the numbers here, it's 1.8 gigabits down and 1.8 gigabits per second up. And we expect these numbers will roughly double when we introduce channel bonding later this year. You'll see one difference when you look at the V5000 talking to a 1000. The 1000 has a gigabit per second interface, so that's not a limit. When you see the numbers drop to about 900 meg uplink and 900 meg downlink, that's not a limitation of the air interface, but rather the 1 gigabit per second Ethernet interface that's on that radio with the V1000. So when you're talking about delivering services to the home, the client node V1000 is really well suited both from a cost point and ROI, but also capacity to give you that gigabit per second speed to the end home or the residence. And then you'll see the last combination there, which is the 1000 to 1000. So let's talk about the different products themselves. Start with the distribution node, which is the V5000. The cnWave V5000 has 2 sectors in it. Each sector is 140 degrees, and each sector can talk to up to 2 other DNs or up to 15 client nodes or a combination. So you can do 2 other distribution nodes and 13 client nodes, and you can do that off of each sector. So from one V5000, leveraging both sectors, you can talk to up to 30 client nodes or up to 4 other DNs. So the reason we distinguish between DNs and CNs is that the DNs really form the backbone or the distribution of the mesh layer. So imagine in some of those use cases we talked about before that you have like the rail yard application where you have DNs down the length of the rail yard. That's what we're talking about when we say DN, is it's this V5000s strung along the end, from end to end along that coverage area, and then have CNs that would branch off of that in a spoke configuration. So we're really kind of blending from the traditional point-to-point and point-to-multipoint to a combination of mesh, point-to-multipoint, and point-to-point. So you really kind of get all combination of topology, and the V5000 is kind of the backbone of that. You can see the 1.9 gig uplink and 1.9 downlink, and then the channel bonding will typically double that capacity up to the real high modulations, where you'll start to see that taper off. But generally, you can think of it as doubling capacity when we introduce channel bonding later this year. Latency less than a millisecond. And let me show you a little bit more about the interfaces on this product. It is a power over Ethernet power supply. You can run PoE injector into this. You can also, we also offer a little adapter that you can run a DC power supply. We have a little dongle that converts that DC and injects it onto the appropriate RJ45 pins. So you can run a DC power to this as well. And then you have a SFP plus port that gives you a 10 gigabit per second SFP module. We have a couple different options available as accessories. And then there's an auxiliary port, which has an 802.3 AT standard output. So I can power typically we either power a camera or a Wi-Fi access point. You could power a V3000, so you could power a backhaul off of this as well. So if you were going to do additional spoke off of this distribution node, you could power that directly from the V5000. So a lot of flexibility. In one of the questions I should mention here is we do get some questions about, well, why is this 280 degree coverage and not 360 degree coverage? And really what we looked at in the design of cnWave and 60 gigahertz is the combining the need for absolute line of sight from node to node and the way that these are typically aligned and distributed down along linear paths, that we could make just about every design, and in fact all of the designs you saw in the applications, without needing a full 360 degree coverage. And this also allows us to do the single channel reuse in all places, and really the other challenge you run into with trying to do a 360, it would be that you're going to have that pole mount behind there that would block the traffic anyway. So really is a nice cost-effective approach, and in the real world delivers the capacity and connectivity that has stood up to all the designs that we've thrown at it so far. On the client side, there are a few different options now. So we have the V3000, which is we call the high gain client. It comes with, has an option for a 44.5 dBi antenna and also a smaller form factor 40.5 dBi antenna, which has just recently been introduced. It is a similar interfaces to the V5000, which I'll show you here in a moment, and similar capacity. So 1.9 gig up and 1.9 gig down. This can be deployed as a point-to-point link. So if you just want to do a very simple point-to-point, connect point A to point B with multiple gigabits per second, this makes a nice solution, great for campus connectivity, building-to-building connectivity, and basically line them up, point them at each other, and you're good to go. Very simple deployment with that same SFP plus port and the 10 gigabit per second PoE in. So you have, again, lots of capacity. So again, this is also a good solution for if you just have a single micro pop or a single Wi-Fi access point that you want to backhaul off of your main building. You could do that with a pair of V3000s. We introduced that smaller form factor, which just basically cuts down the size of the device, and the trade-off, of course, is a little bit less gain. And I'll show you some examples of that here in a moment. The mid-gain client node, which is the smallest form factor, I don't have the dimension. I do have the dimensions on there. You can see it's really 5 inches by 3 inches, so it's like the size of your hand. So the picture doesn't do it justice as far as how small these devices are. But this will give you a gigabit per second up and a gigabit per second down. And this is really that unit that you would use for residential access in a more urban or dense area, when you're within a couple hundred meters of a distribution node. This becomes a nice small form factor for a residence or business application. So this is what we see used most commonly in those types of environments. Oh, and the interfaces on that one is it does have that PoE input port 1 gigabit per second interface. The other thing I should mention on this that I didn't talk about before is that these all have beamforming. So when you connect and point a client node back at this V5000 sector, beamforming occurs at both ends. So I've got a beamform that occurs at each sector 1 and sector 2 on the V5000. And then at the client node itself, it's also forming a beam so that the alignment of these when you're doing multi-point or mesh type environments is very straightforward. You can see that you've got the 140-degree beam forming within sector 1 or sector 2. And then if I come down here to the V1000, you can see it's got a 40 degree plus or minus 40 degree azimuth and a 20 degree plus or minus elevation. And so really you just have to point this in roughly the general direction of the DN, and the beamforming will take over from there and align that and do the fine precision aligning to optimize the capacity. We're also introducing a new in the upcoming release here, 1.1 release, which we expect is in beta now. We expect it to be out into the market around the end of May or early June, is a alignment tool, and it will really make it even easier for point-to-point connections to do that fine-tuning alignment. And then as you watch the beamforming take effect, you'll see the impact there. So it's a nice graphical interface to see how that alignment is going. A lot of the questions that come up around 60 gigahertz, and if you're not, if you're kind of new to 60 gigahertz, the range and impact of rain is kind of a key contributing factor to the design. So I always recommend, just with all of our other products, use Link Planner as the tool for planning these networks. It'll give you it'll take all of these variables and parameters that we're going to talk about here, take all that into account, and it'll give you an output, which is how much capacity can I expect and what availability can I expect. But here's a couple of graphs that show and illustrate a few things. One of the things that limits the range of 60 gigahertz is the oxygen absorption at this particular frequency, and it does impact in the product today. There's 4 different channels available, and you can kind of see that in the 4 different lines on the graph. That's what the differences are. It's channels 1, 2, 3, and 4. And each one of those has a little bit different oxygen absorption characteristic based on its frequency. And that's why you see a slightly different range at each different channel. It's mostly exhibited by channel 4, which you see has that sort of, I guess it's a brownish color that has the longer range in the link budget graph. But and then the other impact, of course, is rain. So what we do is we design these networks with rain, and the link planner even takes into account the geography where you're deploying this link. It will dial in what's the typical rain pattern for that location, and then also what's the oxygen absorption rate, which varies from latitude to latitude as you go across the globe. So we can see here is that this is a V5000 to another V5000. So if you're doing that distribution node down the street, this is giving you a gigabit per second each direction out to about 150 meters. And that's with the average rain throughout the year, and it gives you 4 nines of availability. Now you can adjust all these parameters in Link Planner, but kind of gives you a sense that you can go about 150 meters from node to node on the distribution network, and also 150 meters from the DN out to the CN. Now with no rain, that extends quite a bit further. You can see that range goes out to, as far as 300 kilometers, but you typically design these for the rainy day, and you'll get a much better performance on the sunny day. And that's what you'll see on this on these charts. So this is the V5000 to another V5000, or V5000 to a 1000. If you look at using our higher gain client node, that's the V3000 with the high gain antenna, you'll see those ranges pop out a little bit further. So now that client node can be closer to 300, 350 meters with rain. And if you use channel 4, it can go out over a kilometer if you're on a sunny day situation. So even at the other channels, you can see 1 kilometer. And we have links deployed today that are at around 1.2, 1.4 kilometers around the world at different locations with these products. The last combination, of course, is the V3000 to V3000. This will give you the best range. And this is a point-to-point topology, so not so much the mesh, but now a very narrow antenna beam width, and it's point-to-point. You'll see 400, 500 meters with the rain and extending out 1.5 kilometers to 2 kilometers without rain. So it kind of gives you a sense for what to expect on the performance side, as well as with the range and availability of these networks. So kind of try to get you a sense of what you might look at for deploying or using cnWave 60 gigahertz. So kind of in summary, 60 gigahertz is all about being a great low total cost of ownership alternative to fiber or other solutions that can still deliver gigabits per second of capacity. So combine it with the dual sector. You don't need a switch or router to connect up multiple sectors. You have the single box that you put on a light pole or the side of a building, and it gives you 280-degree coverage. We have a variety of client nodes from the 1,000 to 2 different levels of 3,000 and more of those to come in the future. And then the auto beam forming makes the installation time shorter and more accurate. Long range with the V3000, that does have beam forming, so I can go give you those kilometer lengths with a V3000 at each end. We'll be offering channel bonding with a software release later this year. All of this hardware is I like to say it's designed and built using the same processes that those of you who've been with Cambium for a while know and love the PTP 670. This uses the same design practice, and the same design team that did the 670 is designed to the cnWave. So it's rock solid hardware, IP67 rated enclosures. The density, 30 client nodes per DN, or you can string along up to 4 DNs in a mesh configuration off of that centralized DN. Cloud management, so you can manage the rest of your network with cnMaestro. You can manage these, and for planning, we offer both Link Planner as well as you can look into, and there's a great a video on YouTube about our ANP tool, which is the Advanced Network Planning tool. So you can get access to that and have a look at that as well. So Jocelyn, that's kind of the quick run through of cnWave 60 gigahertz. I'd invite any questions that we have. If you think of a question later on, you can always put it into the come onto our community at cambiumnetworks.com and kind of interact with your peers, other people who are deploying 60 gigahertz, and certainly interact with our engineering team and product team to learn more about your particular application. And of course, I always encourage you to reach out to Double Radius for more information as well. So I'll hand it back to you, Jocelyn.
So we did get a good amount of questions. The first one is, how will Cambium 60 gigahertz solution help with minimizing interference from both with competitors using multiple located PTMP 60 gigahertz without coordinating with each other?
So there's a few things that happen with 60 gigahertz that make it a little bit easier to coordinate. But so some things to think about are the range of 60 gigahertz prevents long range propagation. So it kind of works in your favor as well as against you when you talk about the range of cnWave or 60 gigahertz in general, is that you won't have propagating signals long distances. So that helps, and that's kind of a general 60 gigahertz capability. The TDD air interface and the GPS synchronization is another one that really cuts down on self-interference. And then the fact that you can deploy cnWave with a single channel really gives you that flexibility. Even though there's 4 channels available, you can design the entire network in most cases with a single channel. We do have some customers that have extended that to multiple channel designs, but it does give you some options to if you did get into a very dense area, or if you happened to be competing with someone on the same location, you could do some channel planning or coordination with them on that as well.
All right, question number 2. How many mesh link per access point? What is the antenna coverage for the APs?
Yeah, so I'll go back and pop up that picture. Find it here. So you can see there each sector covers 140 degrees, and within that 140-degree sector you can have up to 30 client nodes. Or sorry, into that sector you can have 15 of those client nodes, or you could talk to 2 other DNs and 13 client nodes. So it's 2 DNs and 13 CNs or 15 CNs in each of those sectors, and then you can do that twice, one for each sector. And don't forget, I mentioned that it's all beam formed within there. That's another way that you help with that from the previous question about interference, is that all of these connections, even though you're talking about 140-degree sector or 280-degree coverage, the transmission is always happening in a very narrow beam width. So that beam width is changing or forming very rapidly. So the overlap of beams would be very minimal. So interference will be much less of a concern or challenge here.
Is there a battery or power supply option for outside deployments, for instance, if it's on a light pole?
Today we support just the general PoE injector. So if you had AC at that pole, you could do AC to DC, an AC to a PoE power injector. We also, I mentioned that there's a little dongle that does DC power. So if you already had a DC power support supply there, and then we have talked to some people about solar power. This is about around 28 to 30 watts of power consumption. I don't know if it says it on the slide or not. I don't think we have it on there. No, but it's about 28 to 30 watts of power consumption. And then if you had something hanging off the auxiliary port, there'd be about another 30 watts or 35 watts for that auxiliary port. But those are the power options today.
How many distribution nodes can you mesh before you need to provide another wired connection in the network? I noticed some of your examples had a good number of DNs, so just wondering how many of those are wired.
So yeah, it's a great question. It really, you can start to do some of that modeling in that ANP tool I mentioned, and really recommend. There's a nice, I think it's about an 8 or 10-minute video on YouTube. If you go and look at the cnWave channel under Cambium Networks, you'll see the design trade-offs that you can make on injecting capacity. So when you do that, you're going to add both capacity as well as resiliency to the mesh. So a lot of it depends on how much capacity you're looking to do. We do offer what we call, and this gets more technical than we really have time for today, but we do offer what's called an onboard eDOE controller that can do 20 different nodes from just controlling it right from within that device. And then when we talk about our virtual machine controller, which is an off-board controller, you can go up to about 500 devices. And then where you inject capacity with what you do is you elevate a particular DN to be called a POP node or point of presence node, and that's where you're injecting that capacity. So I've seen designs where you're putting that fiber injection point every 4 DNs or every 40 DNs. It really depends on what kind of capacity you're looking to inject.
All right, and then the next question is, what product/cost can we start with to get a point-to-point link, and what is the realistic distance for 1 gigabit versus 10 gigabit stable link?
So let me show you those graphs because I think that's probably the best way to think about it. If you're looking to maximize capacity, this would be the way to do that today would be the V3000 to V3000. So you would have this one of these at each end, and you can see the graph here. You're getting about 1.8 to 1.9. Yeah, about, I guess in the theoretical max is 1.9, and the usable is somewhere between 1.8 and 1.9 gigabits per second in each direction. So you'll get about 3.8 gigabits per second total capacity with a V3000 to V3000, and that's at this top line modulation. So this has, just like most of the radios, this has adaptive modulation, and each one of these steps is, as you get further in range, the radio will drop down in speed and the modulation mode that it's using. So if you want to go top modulation mode, you're going out to about a kilometer or so, maybe a 1.2, 1.4 kilometers at the maximum speed. But if you're looking to get just say 2 gigabits per second, you could go out maybe to 2 kilometers. So that kind of gives you the range. And then when you also have to consider that that's with no rain. As you bring in rain into the situation, you might bring it back down to about a half a kilometer.
Does channel bonding require connection to 2 different AP sectors?
No. So the channel bonding is each sector will be able to bond 2 channels separately from each other. So you'd use like channels 1 and 2 on sector 1 and channels 1 and 2 on sector 2, and you can reuse those channels as well.
And do we have to be concerned with GPS for synchronization?
Yes, these do have GPS receiver in them, and it uses GPS as the TDD timing reference. So you do need clear visibility to the sky for the GPS synchronization.
All right, and that wraps up our questions. I just wanted to announce that Scott Wade, you are the winner. We will be reaching out to you just to confirm your address. And with that, thank you guys for joining us today, and that wraps up our webinar.
All right, thanks everybody.